All right, there we go.
You can get halfway to Hawaii right now.
Huh?
You should have a date on the board. It's not
Oh,
there.
yeah. Oh, wonderful job. All right, so this is Charles' law. It relates volume to temperature. It only applies when the pressure doesn't change. So this would be like a situation where you have some kind of container that easily changes its size. So think of like a balloon or a sealed plastic bag that can easily contract or expand, something like that. If it doesn't change its shape, like if we had like an oxygen tank and you cooled it down, then the pressure would drop because the volume can't change. Right, so it has to be a container that can change its volume. All right, let's just do some problems with this. It's really pretty straightforward when we want to do the math. So let's say a balloon's volume is 6 liters, and its temperature, we're really talking about the temperature of the air that's inflating the balloon, right? Of course. Its temperature is, I made it 18, is, I don't know, pick a number.
45.7.
45.7 degrees Celsius. If its temperature is lowered to minus 35 Celsius, what will be the volume? If anybody's really good at math and you stare at that equation for a second, what do you notice is going to happen?
It's going
Okay, the volume is going to be negative, right? And that's not possible. We can't have a negative volume. So something must be wrong. And what's wrong? What's wrong is that we're using a temperature scale that allows us to have negative numbers. We have to have an absolute temperature scale for this equation to work. That means we have to convert our temperature to Kelvin. So as we list our givens, V1 is 6 liters, T1 is 45.7 Celsius. We have to take this temperature and convert it to Kelvin. So 45.7 Celsius at 273, what's that come out to?
Um,
318.7 Kelvin. And then the same thing with T2. Final temperature is minus 35 Celsius. So 273 plus minus 35. That means 273 minus 35. What's that come out to? 200. That's not a 2. 238 Kelvin. All right, so we got all our information now. That's good news. Now we write our equation down. Oh wait, V2 is our question mark. So we'll write our equation down. V1 over T1 is V2 over T2. Solving for for V2. So what do we do?
You're just going to tell me my ratio?
So we're going to multiply both sides by T2, right? So T2 V1 over T1 equals V2. Now we just plug in numbers. By the way, but you should know by now that it's worthwhile to write this down, so when you get problems on the worksheet and I say what's the volume, you already have your solution. All right, so it's going to be 238 K times 6 liters divided by 318.7 K Kelvin's gonna cancel, our answer's gonna be in liters. What do you get? 4.48 liters. Yes.
How did those numbers out?
Which numbers?
The Kelvin numbers.
So if you're converting from Celsius to Kelvin, you just add 273.
Okay.
All right, questions on this?
Alright.
Okay, now, I could give you a problem where I ask you what the temperature is going to be, and there's going to be a little bit more math with that. So let's, I'm going to leave this up here. I'm just going to write it down here, and then I'll erase over there in a minute. Let's call this example 2. Another balloon. Temperature is, what do you want, Anders? 465. Now I gotta edit your name out of the video. Shouldn't have said that. Oh well. 465.
Can you leave it? Just leave it going.
No. I mean I can, but it's more fun if we have to convert. 465 Celsius. And its volume. I wish we couldn't hear you. Volume is 17 liters. Anytime I hear you, I die inside of me.
That's in there.
Why would you write that? Why would you say that?
What?
You
gotta make a whole new.
Where?
Another.
Thank you. Another. Okay. Shut up. Its volume goes down to,
270.
what is it?
270.
It's gotta be less than 17.
16.
16 liters after
Liter.
it is cooled. Yeah, you're fired from doing the numbers.
You make one mistake.
One mistake, that's all you get. What is the new temperature? What's wrong? What are you thinking about now? There's somebody standing in the background. All right. What can I erase? How much do you have? Do you have this? Okay. Let's do this. Let's list our givens again. V1 is 17 liters. T1 is 465 Celsius. And V2, 16 liters. And T2 is our question mark. All right, so here's where it's a little bit more work. And hopefully you don't do that stupid thing where you just plug in numbers without solving. It's just terrible if you do that. So V1 over T1 equals V2 over T2. Remember I told you some of the simple algebra stuff, you kids are going to screw up if you don't take your time. This is it. How are we going to solve for T2? Yeah, exactly. We have to get T2 on top to solve for it. We can't leave it in the denominator. So our first step has to be to multiply both sides by T2. Okay, now we get T2, V1 over T1 equals V2. Okay, from here, there's a fast way to do this or a slow way to do this. The fast way is one step, the slow way is 2 steps. Which one do you want to do? Okay.
No, guys.
Basically, here's how it goes. We're going to have to multiply both sides by T1. And we're going to have to divide both sides by V1. We could do it all in one step, or we could do it one at a time. I don't care. Either way, we've got to get rid of these two things, right? We need to have T2 by itself. So let's do the one step at a time, because everybody's giving me evil looks. So times T1 times T1, that cancels. So we get T2 V1 is V2 T1. And now we have to divide both sides by V1.
So I knocked out.
T2 equals all that stuff.
So that's how you do it.
That's how you do it. And so that's the solution you're gonna need for any problem where asking for temperature. All right, so let's go ahead and, oh, I forgot to convert this to Kelvin. What's that in Kelvin? 730? 738. Okay, that's okay. It really is. All right, let's plug in numbers here. V2 is 16 liters times 738K divided by 17 liters. So obviously you're going to get a number that's a little bit smaller than 738, right? What's that come out to? Yes.
694.5.
Thank you. 694.5. Let's just call it 695. That'll be Kelvin. It's all the liters chances. All right, questions? Okay, so really, if you got these two solutions I gave you, you can solve any of the one from Worksheet. And this one's going to be pretty short.
And you always have to convert to Kelvin?
Always convert to Kelvin, or some absolute temperature scale. It doesn't work unless it's an absolute scale. So we'll always use Kelvin.
What do you add if it's Fahrenheit?
You convert to Rankine, or you go from Fahrenheit to Celsius to Kelvin, either one.